Hi, welcome to StatStuff. I'm Matt Hansen. This lesson is part of an extended series of lessons that cover the topic of building a measurement system analysis, or MSA, which is used to validate the reliability of our data. Please be sure to check out those previous lessons on the series about leading an MSA. But for now, let's review again the 4 general steps for building an MSA. The 4 general steps we're going to use for building the MSA begin with planning the MSA. That usually involves determining what needs to be measured, what MSA tools are going to be used during the MSA, and who's going to be part of the study itself, what samples or masters are we going to use for testing the accuracy, and how are we going to conduct the actual study itself. The next step is to actually conduct the MSA. That's going to involve scheduling the study, leading the study itself, and actually running it, and then collecting the data from the study. Once we've done that, then we can begin the third step of analyzing the results from that study. That's going to involve compiling all the data that was collected during the study, processing the data using the MSA tools that we plan to use ahead of time, and interpreting the results and doing the analysis on that data during the MSA. And then finally, after we've done that, we want to improve the measurement system. That's going to involve determining if we need to make improvements to the measurement system itself. If it does, then we need to find out what are those improvements and changes we need to make to the measurement system. And if we're making changes to the measurement system because we didn't trust reliability before and it failed the MSA, then that means we might have to redo the MSA. And when we redo it, that's a way for us to assess whether the corrections and changes we made to the measurement system were effective enough to the point where now we can trust the results coming out of the measurement system. Now let's dive into that first step and talk in more detail about how to plan the MSA. Well, one of the first things that we need to do when we begin to plan the MSA is to ask ourselves, what is it that we need to measure? Now, one of the things we should always include is at least the project Y, whatever the primary output is. Since that's the most critical metric for the project, then it should be absolutely included within the MSA. But you might want to also include any potentially high impacting X's or inputs that you had identified, such as in the cause and effect matrix or C&E matrix. You might also want to include any additional metrics that are considered essential for this analysis. And do measurements from a system need to be included in the MSA? Well, maybe. System-generated measurements will usually have better precision than some of the manually based type of measurements. Many prudently managed systems normally undergo some accuracy and precision validations anyway. However, if there is a potential risk in the integrity of that system, wherever that metric is coming from, then the MSA can help measure that risk. Also, we want to ask ourselves what MSA tools are going to be used. Well, there are 2 basic tools that we'll review, and it's going to depend on the type of data that we're analyzing. If it's discrete data, then you could use either the attribute agreement analysis or a multiple attribute R&R. Or if it's continuous data, you can use a gauge R&R study. Now, if you require an MSA that's on both data types, then both types of tools are going to be necessary. The difference may affect how you collect the data and eventually in how you set up for analysis in the tools. Now, who's going to be a part of the study? Well, you're going to need to at least decide that up front who's responsible for recording and collecting the data. A general rule for testing the reproducibility is to use at least 3 different operators if possible. The operators should represent a typical skill level. That is, you don't want to purposely include people who are very strong in expertise of whatever the process is. As well, you don't want to just use beginners or novices in it. You want to have it represent the average or normal type of people that are normally operating this type of process. Next, we want to ask ourselves what samples or masters will be used. That is, masters referring to the set of accurate items that we're going to be measuring, the actual master that we're going to use for testing accuracy. So that's what we're going to use as our standard when we want to validate accuracy and precision. And in a manufacturing environment, those could be sample products or customer production requirements, or if you're in a transactional environment, that could be something that's like a set of existing transactions or measures that are approved as accurate. The master process outputs should be randomly selected because you want them to represent the process variation. Now, a general rule if you're going to be testing this is you want to include at least 10 to 20 different process outputs. And you can include even more. I've done some that's included 30 to 40 because we just had that capability and it wasn't an additional burden on the operators for that type of test. But you want to at least include 10 to 20 different process outputs if possible. If that's not possible, then what you generally want to do is try to select enough samples so that you at least, when you compare the number of samples multiplied by the number of operators, that it's at least going to be greater than 14. Now, you also want to finally ask yourself how you're going to conduct this study. A plan should be developed that outlines several things, such as when will the MSA begin, and who are the operators that are going to be a part of the MSA, and how will the process outputs to test be distributed to each of those different operators. When will the process outputs be distributed to the operators for each of those review trials? And when are the operators expected to return the results for each of those review trials? And what processes are the operators expected to follow for the review process? Such as, is there a specific SOP or standard operating procedure that should be referenced when you want them to pull a certain type of data for you? Are there any specific criteria or requirements that you're expecting those operators to follow? Also ask yourself, will calibration be done before the MSA begins? If it is, then when will that calibration begin? I strongly recommend calibration not be performed during the MSA. If you're going to do any calibration at all between the different operators, make sure it's only done before the MSA. And if there's no calibration that's done before the MSA, then at least your results from the MSA is going to most likely reflect the true as-is process. So if you have to do calibration, that's fine. Only do it before the MSA begins. Whatever you do, under no circumstances, conduct any calibration at all between the operators during the MSA, because that will change the results, and that will defeat the whole purpose of even having this MSA in the first place. Finally, you want to build a document or template that the operators are going to use for when you want them to collect this data. They're probably going to require some understanding of what the data is collected and what MSA tools are going to be used. And this is going to be reviewed in more detail when we get to the third step for analyzing the results. Now let's jump into the next step and talk in detail about conducting the actual MSA itself. One of the first things you want to do when you're conducting the MSA is to schedule the actual MSA. This is where you want to begin to execute the MSA plan that you had previously developed. You want to do this by beginning to coordinate and schedule the MSA with all the operators and analysts, all those people that are going to be involved in the process. Pull the sample that you're going to actually have them use and use it as your master data set. You also want to distribute to the operators the document or whatever way those operators are going to use for recording the data. Now, you want to do this to ensure that the operators have a full understanding of what data you're expecting them to record for the study and how you want them to go about recording that data. Ensure the operators understand the deadlines for providing the data. This isn't intended to be, again, a calibration. It's not intended to instruct them on how to pull it. You just want to instruct them on how you want them to record the data that you want them to pull, because you're trying to assess how they're doing the recording of the data and the reliability of the data that they're actually recording. The next step you want to follow in conducting the MSA is to actually go ahead and lead and collect the data from the study itself. This is where you begin it. Now, if you're observing the collection of the data from the operators, then try to observe and document some additional things along the way, such as any process deviations that you happen to observe or any environmental changes that occur along the way. Also, any differences in the skills or behaviors you might observe between the operators that are involved, or any observable errors in data entry, or any observable errors in the use of the measurement tool itself. But whatever you do, do not calibrate nor make any process changes during the MSA. So even though you might observe some errors or observe some things going on, it's okay to record those things that they happen at certain times. You might want to flag it in some way, but whatever you do, do not correct or change or calibrate in any way the method that are used by the operators. You want those errors to go through, because that'll be, again, the whole point of trying to assess the reliability of this data. And if it happens to have errors that come through, then so be it. That's the exact type of thing you're trying to assess anyway. All right, before we close this lesson, let's discuss how we can apply some of these concepts in a practical way. Well, due to the nature of the MSA itself, there really isn't a practical application you can apply for these first two steps for planning and conducting the MSA. Now, despite that, you can review the suggested steps for how we would say you'd want to plan and conduct the MSA itself. And then you might want to ask yourself, how do those steps differ from other methods that you may have seen for validating the reliability of data? But if you do find that there is some data that you want to validate and you want to test the reliability of it that maybe isn't for a previous project or initiative you worked but something you want to do now, then you absolutely want to apply these types of steps in doing that part of the test. But again, otherwise, if you hadn't done that previously, then it may not be as practical to apply to a previous situation. Well, that wraps up this lesson. Check out StatStuff.com for many more resources that can help you achieve powerful results. I'm Matt Hansen. Thanks for watching.